Alright, today we're going to go over how to use an electrostatic spray gun. We're going to cover the features and benefits of why you may use an electrostatic versus an air spray gun, and go over proper safety instructions that you should consider when doing electrostatic painting. So we'll go over all that today. Enjoy this training, and if you have questions, you're welcome to leave a comment below or send us an email. Alright, the first step in understanding and using an electrostatic spray gun is to cover how it works. So it's much like any other spray gun. Electrostatics are typically available as air assist airless or HVLP versions. So either you're using an air spray gun or an air assist, which you can refer to our video on the differences between the two if you're trying to consider which one would be better for you. But as a general rule, air assist airless is a little faster and better for high production. So material comes through the gun to the tip, much like in an air spray gun or any regular spray gun. We also have an air line, and then we have electricity here, or current. So when the material comes to the tip, air is introduced. If it's air spray, if it's air assist, the high pressure uses the tip to start atomizing the coating. Then your assist air gives you a final breakup for a little bit of a finer finish. The main difference between this and a standard spray gun, either airless, air assist, or just an air spray gun, is that we have a little tip here that introduces an electric charge to the paint. So that electric charge actually typically will negatively charge the coating, and the product that you're spraying, or your target, will be connected to a grounding rod. We'll go over how to ensure your product's grounded in a moment. But the negatively charged paint will want to seek a grounded surface. So what you'll see is that as I spray the paint at the product, the paint will naturally attract to the surface. Now, that means reduction in overspray is one of your biggest benefits of electrostatic, because as we spray past the part, with a normal spray gun, that becomes waste. With electrostatic, we then are able to wrap back towards the surface of that part because of the desire for the negatively charged paint to seek ground. That can result in savings of anywhere from 15 upwards of 25% in your coating waste. Now that's quite a bit of an savings, but there's also a significant cost difference. A standard electrostatic outfit can cost in the $5,000 to $6,000 range versus an HVLP spray gun or air assist gun that while HVLP would cost anywhere from $300 to $900, and with a pressure pot, or if you're looking at an air assist with a pump, you might have a $2,000 or $3,000 charge, but this would be in addition, if you're using air assist like we are here, to the cost of your pump that you use to supply material and air to the air assist gun. So the important thing is, because we have an electric charge, safety is very, very critical. Specifically, we never want to create the opportunity for a static discharge, where the electricity builds up in this gun and could potentially seek ground as we get too close to a grounded surface, causing a spark to jump, which could serve as an ignition source for your coating, or just give you a really bad scare and a shock. So important safety principles: the way the gun is grounded is through a few different means. First, we have a power pack that we'll show you here in a moment that goes back to the wall and is grounded through the wall. Now you want to make sure your wall source actually has a grounding prong that's actually connected. So that's source one, is the electric cord. And we also want to make sure we have all three prongs on our unit that we're using to plug in. I've seen times where someone might cut off the third prong to work with a two-prong outlet, and that right there will eliminate that source of ground. Your second source of potential ground is through your body. So that's why we always want to work with an electrostatic gun, have our hand bare, or at least have the palm of our hand bare. By keeping my hand on this unit, I'm actually able to allow current to flow through me, and then with proper shoes that are conductive, so shoes that have thick rubber soles, metal, or similar features may keep you from being grounded. But as long as you have shoes that are conductive and your bare hands connected to this surface, this plastic allows for the charge to be passed through you into the ground and eliminating any buildup of electricity. You'll know relatively quickly if you are building a charge. You'll feel almost very similar to when you're shuffling your feet across the carpet, but on a very higher scale. You'll feel your shirt stand up, your hair may stand. If you notice that, most likely your shoes aren't properly allowing you to ground, or your wall ground isn't correct. Essentially, you're building a charge. If that occurs, you need to stop, and you need to safely remove yourself from the painting area to properly remove that charge safely. And that would be a good time to check your electric source, as well as your shoes, as well as your just unit as well that you're spraying from, to make sure it's grounded. Grounding is the key for safe electrostatic spraying. So once we know we're grounded and our equipment's grounded, those are your two main sources of ground. We also want to make sure our part's grounded, because without a properly grounded part, the paint will not be attracted to it. It'll simply just go in the direction, and you'll really not receive the benefit of electrostatic painting. So we'll show you how to ensure your product's grounded here in a moment. Obviously in this booth, we'll show you what that looks like so you know when it's grounded. But once we're there, from that point, we use basic safety principles that you use with any spray equipment. If you're using air assist airless, you never want your hand in front of this gun, so you'd avoid injection injury. Obviously we're going to wear safety glasses, and we're going to wear a proper respirator that's designed correctly for the particular material you're spraying. So we'll go ahead and show you how the equipment works, how you get this set up, and some of the details of settings, and as well as the product and how it's grounded, and go from there. All right, so as we mentioned, you have to make sure your product is grounded to be able to electrostatically spray effectively. So this would be kind of a common setup for an electrostatic spray application. This may resemble an overhead conveyor where products are moving through at a certain rate, or you may also connect it to the ground. It just depends on your need. What we have here is a grounding strap, comes back to my booth and secured into the booth. Now ideally you may use a grounding rod as an alternative, but the important thing is that you verify that your product is grounded so that we don't increase the chance of an electrostatic discharge, as well as ensure that we actually get the benefits of increased transfer efficiency and paint savings. So one way to verify that is by using a grounding tester. That's what this tool in here is. It comes to a cable which connects back to my booth, and I verify that back to my booth here where I know it's grounded. You basically need this to be a verified ground wherever you're connecting it. Now what this does is on top here you can see there's some lights. And so green, the far left, would be your best source of ground. That would be suggesting that you have a perfectly grounded target, and any electrostatic spray will be very well effective and efficient. So we go ahead, our product's supposedly grounded, but we're going to verify with the tester. I put this on the surface, I pull in the trigger, and I see it's grounded. Now what if I take the strap off just to show you? This is my grounding cable. Now if I check ground, I may still be grounded through this top connector, but we'll find out. So in this case, I'm still grounded. Now if you found that you weren't grounded, you want to verify what's causing that to happen. It could be paint buildup on your conveyor or on your hook, a poor ground to the booth. There's a variety of situations, but you'd want to verify before continuing. So now we know we have ground, we're going to show you how to use the electrostatic gun. All right, so a couple other quick things about electrostatic. They typically work best with solvent-based materials that are relatively non-conductive. Conductive material will tend to bring the charge through the paint back through the unit and ground out. So water-based is a little bit more of a challenge, and some solvent-based materials can be more challenging. They do have low resistant hose and water-based designs for electrostatic units. So if you are going to be using water-based products or products that have conductivity to them, especially like metallic-based coatings in similar situations like that. You do want to consider at least a low-R hose, and you may need a water-based electrostatic gun. Other safety tips: make sure you're wearing a respirator and eyeglasses, and then we'll show you how this unit works. So first we have this is our air assist pump. We have material here that we're going to pick up. And first we're going to start by cycling the unit to get the material through the pump. So I got up here, I let air go down to my pump. We'll turn the pump pressure on, and we'll make sure our bleed off valve is open so that our material can circulate through the beginning of the pump. Do this slowly and gradually. You'll feel the pump jump to life around 20 pounds. Okay. Then we're just going to wait till we start seeing material come through my pickup tube. This is priming the initial part of the pump for spray. You can see I'm starting to prime, and from there we got to prime the line out to the gun. All right, so for once we get the initial pump primed using our return tube and our pickup tube, next we can set up the actual gun. So we start increasing pressure here. This operates like an air illus or an air assist. So the pressure is our first way to break up the coating, and then second is our assist air. So I have it at about 40 pounds, and it's out to the gun at this point. And so we'll show you what we're looking like from a test pattern standpoint. Now I have my electricity off because I'm not shooting at a grounded surface, so my power pack for the unit is off. That's usually an ideal way to do it. If you're using air assist, start with the electricity off, same with air spray. And once you get the settings in with your basic paint settings for pressure and air, for air and fluid pressure, then you could turn on the electricity. All right, so looking at that, my pattern's pretty good. I'm using a 15 thousandths tip. You'd want to make sure you don't have too much material in your pattern. You can see I do have what we call a slight bit of fingers at the top, so I will increase my assist air and my pressure to bring that, kind of fine tune that in and get rid of those fingers. So bring up our fluid a little bit. Now you do want to make sure too with this electrostatic unit, at least this air assist, there are limits on pressure to the gun. It's rated at 4,000 pounds. So this is a 30 to 1 pump, so I know I won't over pressurize. But I'll bring up my assist air. Usually 10 to 20 pounds is as most as you want on assist air. So I brought up my fluid pressure a little, which helps get rid of the fingers. Then I bring up my air pressure a little to help get rid of the fingers. We should see those fingers disappear a little more. Okay, so you can see there that I'm getting pretty good breakup, pretty fine breakup. Obviously this isn't quite a car finish, but this isn't for an industrial product. It's PPG, industrial enamel. So for that purpose, this is a pretty good breakup. You can see on the edges there how I do have pretty good small particles. And now we have the actual air assist setup, we can go ahead and begin to spray the product. So this is my control pack. What you notice on the left is KVs. KVs, in a lot of ways, the higher the KV, the greater the wrap. So we typically want that to be relatively high. Only reason you wouldn't want that high, if you're dealing with a Faraday cage area, sometimes you can drop the KV and by doing that, help with Faraday. Faraday is when the paint is attracted to the corners of a surface instead of the interior, and that's because the corners are closer and are grounded compared to the center of the surface. So we'll show you what the standard settings look like here. As we mentioned, we tested our product for ground. Alright, so once we have the gun set up to spray right and have the pattern all set, next we're going to look at our KVs and microamps. You can see my KVs in this sense, which are on the left, are very high, and my microamps are in the middle, or very low. KVs and microamps move in opposite of each other. So as KVs are high, you usually see microamps drop down. Typically, I work with just the KVs if I need to change any settings. In this unit, I do have 3 potential programs that I can program it with, but the higher the KV, the better the wrap. But in corners, the high KV can create a problem. We're going to show you what electrostatic will offer you by shooting the target here and leave the KV high so the wrap's pretty strong. So my product's grounded, and I'll start painting from here. So you can see I could paint next to the target completely, yet I'm still getting paint on my surface. That's due to the attraction of the electric charge to the product. So if I paint it directly and we flip around the back of the surface, you can see I'm getting paint on there even to a certain extent. That's due to the wrapping effect of electrostatic. You can see I set my settings pretty well because the paint's looking very smooth as a finish. And we'll show you what this same product would look like without electrostatic with me shooting next to it. Now we'll also show you the issue that comes with Faraday and how you can kind of overcome that. Some of the other key things, you use the same spray technique that you used with HVLP if you're using an air spray electrostatic, or an airless / air assist airless if you're using an airless air assist electrostatic. For air spray, you'll be 4 to 6 inches from the target. With airless or air assist, you're going to be closer to 8 to 12. The tip size on an air assist is the same selection that you would do with an airless. So if you're already using an airless, you're looking to reduce waste, and you're considering electrostatic, your tip size, your air cap, all those settings between airless, air assist, and HVLP would all be about the same. You don't want to get excessively close to the surface because that can create a potential for static discharge. But these guns actually do reduce KV as they get close to a surface, which limits or even eliminates the potential issue of a static discharge, as KV is what typically is driving the potential for a static discharge. So to give you an idea here, some of the challenge you have with electrostatic is that certain corners and crevices, like you see here, are problematic. You can see there's no paint in there. Even aiming at it, I tend to get a pooling on the edges, even though it's a little tough to see. That's because by nature, my charge is drawing my coating to the sides, so that side and over here, rather than deep in the crevice. You can see how it's dripping there. That's because of that draw to the edges and what we call the Faraday cage. So to address that, I can either drop the KVs on my unit significantly, or I can even just turn off the electric charge completely. As I drop KVs, that charges the paint less, which will help it go in the corners without the same issues occurring with Faraday. So that's kind of the Faraday cage principle and the issues you have and what you do about it, and then also some general principles on using how you set the electrostatic spray gun for best results. We're going to show you what happens if you don't have electrostatic, to show you kind of the waste that you might be missing, or you might be creating using a standard spray gun, so you can better evaluate if that's a good solution for what you're painting and what you do. All right, so now we're going to show you what the electrostatic looks like when the electrostatic charge is turned off. So at this point, we're working like a standard air assist airless. You can see I don't have any paint getting on my surface to the product at all. Now obviously this is a little bit of an extreme case. You wouldn't ever miss a product completely, but this is just to show you how much potential benefit electrostatic gives you. Particularly if you're painting tubular or angular structures and parts, the wrap can save you a ton of paint. So we'll show you that now. All right, I turned my electrostatic unit back on. My charge and KV or about as high as I can get it to go. I'm going to aim next to the surface of this product. You can see, because of the wrap, the electrostatic charge, I'm actually painting the surface of this product by aiming next to it. So that's why you want to use an electrostatic and the biggest benefit it gets. Now obviously if I'm going to shoot the target, anything that goes beyond it wraps back around it. So as I come around my surface, I've actually painted the entire pipe by shooting the front. And that's the benefit of electrostatic. That's a significant opportunity to save paint. Now obviously you have the safety and use challenges that you have to learn a little bit to properly use it. But if you're able to, it has a potential benefit. And there's a lot of opportunity out there to calculate how much potential paint you could save. And we'll link to that below so you can do a paint calculation to see if it makes sense on your product and your paint job to save on your cost of paint.